Engineering Practical Lab. This time around, we want to talk about connection of resistors, both in series and in parallel. In the first place, why do we need to connect two or more resistors together? So whenever we need a resistance value and we don't have the resistor that can give us that value, we don't have that resistor that can give us the exact value that we need. So we think of connecting two or more resistors together to give us the value that we need. When we connect two resistors together, total resistance equal to the first resistor plus the second resistor. That's how to know total value of a resistance value, resistor connected in series. If you have connect two or more resistors in series, you just add it together. So it's going to give you total value. So for example now, so if we have R1 to be 50, then we have R2 to be 50 as well. The total, when you connect the two in series, total resistance will be 50 plus 50, which is equal to 100 ohms. It means that whenever we need 100 ohm resistor and we don't have 100 ohm resistor, what we have is 50. We can combine 250 ohm resistor together in series to have 100 ohm resistor. That's what it means. So, for example, another example, when we need, let's say we need 1000 ohm resistor, but we don't have that value. We don't have it in our lab or in our store. What we have is 500 ohms resistor, maybe 2 or 3 or 4, 500 ohms. That's what we have, and we need 1000 ohm resistor. What we have to do is that we connect the two resistors together. 500 ohm plus 500 ohms resistor will give us 1 kilo ohm resistor, 1000 ohm resistor. That means when we need 1 kilo ohm resistor, we can combine 500 ohm resistor two together in series. That means we connect the end to end together. So we're now going to have our output here and here. So our resistance value we have one here. This is our output. Our output will be from here. We connect our output from there to give us the resistance value. We have our output from here to give us the resistance value that we need. So whenever we need this might be the input from here, then we have an output, we have our input, and we have our output. So whenever we need a resistance value and we don't have that value, we connect two resistors in either series or parallel. But connect it in series will be the sum of the resistor. So let's now talk about the parallel. So when you connect two or more resistors in parallel, total it will be, let's talk about two resistors for now. Let's talk about two resistors because I will connect two resistors in parallel. Multiply the two resistors together and add it, divide it by the addition of the two resistors. For example now, let's say we need 500 ohm resistor. And what we have is 1000 ohm resistor, 1 kilo ohms. We need 500 ohms. But when we check our store, what we have is 1000 ohm resistor. We can connect these two 1000 ohm resistor, we can connect two in parallel to give us this value. So let's say the first, if R1 is 1000, let's do it like this. If R1 is 1000 ohms, this which is 1 kilo ohms, and R2 also 1000 ohms, which is 1 kilo ohms. So we can combine the two together to give us 500 ohms. We now say total resistance equal to 1000 times 1000 over 1000 plus 1000. So from there now, this one will give us total value will be equal to 1 million divided by 1000 plus 1000, that's 2000. So this cancel this. So 2 here, 5. So total value of the resistance will be equal to 500 ohms. So that means if we need 500 ohm resistor and we have 1000 ohm or 1 kilo ohms in our store, we can combine the two in parallel to give us 500 ohms. So you can see the reason why we need to connect resistors in parallel and in series now, because whenever we need any value and we don't have it, so we have to think of how to, and let's look at this. This one is not well drawn. We have, okay, it's like this. It's like this. So parallel. This is R2. This is R2. And it will come like this, and we're going to have our output, our input, and output. Input, output. So our input, output, then our input, and the output from there. So we can combine, this is how to combine two resistors in parallel. So we need 500 ohms, but we have 1000. We can combine it in parallel and have 500 ohms. So if, let's say, for example, we need 250 ohm resistor. We need a 250 ohm resistor, but what we need is 250 ohm resistor. What we have is 500 ohms. 250 plus 500. So that will be 1000. This one plus this is 1000. So this 30 cancel 30, 230. It remains 250. That means total resistance will now be equal to 250 ohms. So if we connect 500 ohm resistor 2 together in parallel, so we're going to have 250 ohms. It means that whenever we need this value and we don't have a resistor that have that capacity, that have this resistance, if we have 500 ohm resistor, we can combine the two in parallel and to give us this value. So that's that about that. So let's go to, now let's see how we can connect two resistors on breadboard. You know, I've explained this breadboard before. Look at our videos on how breadboard is being designed. You know, from here up this line, they are joined together up to this place. There's a breakage here. This one also joined to this place. There's a breakage here. So likewise here, they are joined together. This one also joined together. So all this one, they are not joined with all this one we have here. All this one that we have here, all these vertical lines, 5 on the line, on the row, on that column, 5 on this column, 5 on the, each of these 5 on each column are joined together. But they are not joined in this way, but they are joined like this, 5. Even this one we have here, the same thing. All these 5 O in each column here, they are joined together. They are not joined with this one. There's a breakage along this line. The same thing, horizontal line that you have here, from here down here is joined to this place. Likewise here. It means that this is, let's look at these two 1000 ohm resistor. 1000 ohm resistor. If I want to join these 2000 in series, that means I have to join the end to end like this. I have to join it like this. This is series connect. This is series connection of these two. I've joined it in series like this. So I've joined it in series. But if I want to use breadboard to join it together, what I will do is that I will find a spot that they are joined together. I can use, if I want to use this line up here. So if I put one here on this line, so I might put another one here. I might put it here. All this line they are joined together. If I put it here, that means I've joined the two resistors together in series. I can place this one here to any line here. I can place this one also any place here. Any place. If I have something like this, I have it here, I have this one here. So these two resistors now, they are joined in series because these two up, they are joined together, but this one are not joined. So if I want to measure total value of resistance now in that one, so I will place it here to know the value of, you know, it's two 1000 ohm resistor. I will now place it here. You can see what it give me, 1.976 kilo ohms. That's almost 2 kilo ohms, approximately 2 kilo ohms, because I have 1 kilo ohm resistor connected in series. What did I have? So have you seen it now? So if I move it nearer, the same thing. If I put it nearby this thing, the same thing. It's going to give me the same thing because all these lines are joined together. If I decide not to use that one, if I want to use this, if I decide to use this or this column, so if I put anyone on this line, on this hole, so I have to place this one down. If I want to join it with this one, I have to join this along this other 4 line. If I place it here, it will not join. I have to place it. I have 4 slots left, 4 holes left. If I want to join, if I put it here, so it will join together. I've joined together like that. If I decide to put it here, I've joined together like that. But if I put it beside or here, they are not joined. It's only this line. If I put it here now, and I put it, I can place this one anywhere here. It means that I've joined these two legs together like this because they are on the same line. I've joined these two legs together. If I want to measure the total resistance now, I will now place it. Can you see now? They are joined. But if I place it beside, somewhere like this, if I did not put it on the same line, so if I put it side, so it will not read because I did not join it. Can you see now? It's not because it did not read, because I did not join it. It will not join in any way. You see now, that's how to join two resistors in series together. So in series, that's how to join resistors in series. So if I want to connect these two resistors in parallel now, parallel connections means the end-to-end connection. I will connect this side together. I'll place this in together like this, and I will join this one also, the other end here together. So this is parallel connection of two resistors. So it will now, if I want to measure now, I measure from these two sides. Measure, put one here and put the other one here. You can see now, which is, so that means, let's put it to lowest value. So we have 492 ohms, for almost 500 ohms. Have you seen it now? Because we joined two 1000 ohm resistors in parallel, we now get 500 ohms because we join it in parallel. You know, when we join the two in series, we get 2000 ohms. In parallel is 500 ohms. 493 ohms. So let's now use breadboard to join together so that you understand what I mean by series and parallel connection of resistors in series and parallel when we're talking about the breadboard. So I have to join these two legs together. Now, if I want to join this one together, I have to look at the line that are joined together. All these lines now, they are joined together. If I put one leg here and I put the other one here, at it now, I'll put that one. So if I want to join this one with this one, I have to put it on this line. If I put it down here, it will not join. But if I put it here, it will join. That means I've joined that one. If I want to join this one also, I have to put it along this remaining line. I have to put it along here, along this line. So if I do not put it there, so it will not join. I have to put it, they have to be on the same line. On the same line. You see it now? Now on the same line. So, but here on the same line here on the vertical line. So this thing I've joined it together now. So let's now see the value. What will be the value of the resistance? You can see now the same value now. 493 ohms. That's parallel connection of resistors on breadboard. When you connect these two resistors in parallel like this, you're going to have 500 ohms because it's 1000 ohms resistor. Let's do it the other way. Let's say if I want to use this place, if I use here, let's say I use here, I put one here. If I want to join it with another terminal, I have to join it along this line. I have to join it here or here or here. Even if I put it here, they are joined. I've joined it like that. So if I place this one in anyone here, so I have to join this. If I want to join it with this one, so I will have to put it on this either here or here. All this, they are joined together. If I put it here, it will not connect because this one, they are not connected. So, but all these lines are connected. I have to put it here. So, or I can put it here. So I've joined it together like that. If I want to measure the total resistance, I'll place it here. You can see now. You can see 493.8. That's almost 500 ohms because these two resistors are connected in parallel. Thank you very much.